Section 7.6, factoring ax squared plus bx plus c. This is the same as the last section, except now we're going to have a coefficient in front of our x squared other than 1. And so we're going to try to figure out a way to do these problems because it's a little bit different than just using the x puzzles that maybe we used to figure out the last one. It's very closely related though. Here's an example. Maybe we have a problem, 3x squared plus 5x plus 2. And I've actually shown here that in its factored form that would be 3x plus 2 times x plus 1. We could check it by using any of the methods to multiply polynomials, FOIL, Punnett square, distributive property. So I'll show the distributive property here. First I'm going to start off with 3x times x, which is of course 3x squared. I'm going to do 3x times 1 is plus 3x. And do 2 times x, that's plus 2x. I'm going to do 2 times 1 is plus 2. And I have my little crab claw up there to make sure I've done it right. Combine the two terms in the middle, and I get 3x squared plus 5x plus 2. And that's exactly the same as my original, 3x squared plus 5x plus 2. It's in standard form, and so I know I've got it right. The question is still, how did I get there? Because there's a lot of different ways that we could try it, and we want to make sure that we get it right as quickly as possible. So let's figure out how we would do this going forward. Sometimes when you have a coefficient in front of the x squared, you're able to simplify your problem by factoring out the greatest common factor, or the GCF. You'll notice that 5x squared, 15x, and 10 are all multiples of 5. So just like we did before, we can take a greatest common factor out of all three things. So I'm going to take the 5 and put it in front of a set of parentheses. And now think, what, or 5, excuse me, times what gave me 5x squared? Had to be x squared. Similarly, 5 times something gives me 15x. It's got to be a positive 3x. And finally, 5 times something again would give me the 10. I distribute this 5, it should bring me to the 10. It's going to be a positive 2. And if you're not clear on how we did that, it's just a matter of, you can check it using the distributive property. If you distributed the 5 to all three of these, you'd come back here. So that factoring of the GCF is basically a reverse distributive property. Now that we have x squared plus 3x plus 2, that's a regular polynomial that I can factor. I can use my x puzzle if I want. I need numbers that multiply to 2 and add up to 3. Only option is 1 and 2. So when I bring it down, I'm going to have x plus 1 and x plus 2. One thing that's important to keep in mind, I've got to bring my 5 down as well. That's part of my factored answer. And there you go. That's the case where it's really, really easy if you happen to have a greatest common factor and it makes it just an x squared instead of an ax squared. All right, not always going to be that easy though. Let's take a look. Okay, so let's look first at an example, a couple of examples here. And I say here, when AC is positive. So AC is the product of my first coefficient, my lead coefficient, and my constant. And that's going to be an important thing here because that's actually something that I'm going to look at. I'm actually going to take this and multiply these together first. 4 times 3 gives me 12, and that's a positive 12. I'm now going to put that 12 into an x puzzle up on top, like the number normally would go at the end. And down the bottom, I'm still going to put a 13, and that's what I have there. So now what I need to figure out is the numbers that multiply to 12 and add to 13. Pretty quickly, we find that that's 1 and 12. Now, unfortunately, I cannot just say then that my answer is going to be x plus 1 times x plus 12. The reason for that is if I actually did that multiplication out, I'd see that I don't come back to my original problem. So this is not true. Instead, this is what I'm going to do. I'm going to rewrite my original problem, but instead of saying plus 13x, I'm going to write it using the 1 and the 12. So that's plus 12x plus 1x plus 3. And you can write it in either order. You can do plus 1x plus 12x first. It doesn't make a difference. Now here's where it gets a little tricky. You have to look at your first two terms, the 4x squared and the 12x, and say between the two of them, what is their greatest common factor? That's what we're looking for here. The greatest common factor of 4x squared and 12x is 4x. And then that would leave in parentheses an x plus 3. That's just from that first part. The second thing we have to look at is the second batch of numbers, plus 1x plus 3. Once again, look for the greatest common factor. They don't have a greatest common factor, so what I'm going to put out in front is a plus 1. And now, in parentheses, what I'd have to, what I'd have to leave in there is an x plus 3. Now, this is new. This is something we haven't done before. So to reiterate what we've done, after solving the x puzzle, I rewrote 13x as 12x plus 1x. I think you can see that that would come from basically uncombining like terms there. 12x plus 1x is the same thing as 13x. Then I take my first two and look for the greatest common factor and factor it out of the first two. Same thing for the second pair. The 1x plus 3 don't have a greatest common factor, so it's just always going to be 1. And then that would leave me with just the x plus 3. Now what's important here is that x plus 3 is the same in each of these. When that's the case, I take this entire expression, x plus 3, and I'm going to put it in front of the rest of my answer in parentheses, just one of them. Then what remains in my parentheses after it is whatever was left outside of the parentheses. That's 4x plus 1. And that's what you have. That is going to be your final answer. You could multiply through to double check it, but trust me, it works. Now again, that's the first time we've seen this, so I don't expect you to 100% have it at this point. We're going to try doing it again with the next problem and see if it makes sense after seeing it again. 3x squared minus 7x plus 2. First thing that I do is I multiply 3 times 2, and I get 6. Now I'm going to set up a little x puzzle. 6 goes up top, negative 7 goes on the bottom. What numbers multiply to negative 6 and add up to negative 7? The only way to do that is negative 6 and negative 1. And so now I'm just going to rewrite my negative 7x using the negative 6 and the negative 1. So that's 3x squared minus 6x minus 1x plus 2. Now we're going to look for GCFs. We're going to split it up into these two parts here. We're going to say here's the greatest common factor of this part. What's the greatest common factor of this part? 3x squared and 6x both share a 3, and they both share an x. So that'll leave behind an x minus 2. Now remember from the last example, I want to have an x minus 2 in both sets of parentheses. So when I look at the negative x plus 2, in order to make that x minus 2, I'm actually going to have to pull out a minus 1. And that's going to leave behind an x plus 2. That's the only way that I could turn, I'm sorry, let me fix that there. That's going to be x minus 2. Sorry about that. That's not good. That's the only way that I can get these things to be exactly the same, which is really what I need there. Then I take that, x minus 2, put that in front, and what's going to remain from parentheses is the 3x and the minus 1. And there you have it. So just another example of how we can factor. I hope this is starting to make a little bit more sense. And so one last thing you'll notice is that these were two cases where AC, the product of the first coefficient and the constant, was positive, 12 and 6. Then our final factored form, both of the signs are pluses or both are minuses. And they're actually both going to be the same sign as whatever was in the middle with the x term. So that's just another way you can keep track of it, make sure you're doing it the right way. All right, so what we might be expecting here is trying to come up with a different situation, because now A times C is going to be negative. And all that means is that our final answer should have one addition, one subtraction in our two binomials. So same steps as before. Going to multiply 2 times negative 7 and get negative 14. Make my little X puzzle. Negative 14 up top, negative 5 down below. What numbers multiply to negative 14, add up to negative 5. 7 and 2 are going to give me negative 14 if I make one of them negative, and I guess the 7 would have to be negative to make them add up to negative 5. And so now what I'll do is I'll just rewrite my expression. 2x squared, instead of minus 5x, I'm going to do minus 7x plus 2x and then minus 7. Once again, the order doesn't matter. Your work would look a little bit different, but you'd arrive at the same final answer if you did it the 2x before the negative 7x. Look for the greatest common factor in each of these pairs. That's what we're looking for. You don't need to write GCF every time. This is just a reminder. 2x squared and negative 7x. Well, the 2 and the negative 7 have nothing in common, but they do share an x. So I'm going to take that x out. 2x minus 7 would be left behind. And since that's actually what I already have in my second pair, I'm going to think about this as factoring out a 1, which normally I wouldn't think about writing, but it's going to be helpful when I rewrite my factored form here. So I have the 2x minus 7 is what's shared. That's going to come out in front just once. And then the x plus 1, you see the x and the plus 1 is going to go in the second set of parentheses there. And once again, you could multiply through and check, but that is the factored form of 2x squared minus 5x minus 7. And once again, since when I multiplied my lead coefficient by my constant, I got a negative, I got what I expected. 1 addition, 1 subtraction. And we're in good shape. All right, now it's your turn. Here are 4 problems that need to be factored. None of them are prime, and I want you to go through each of these problems after you pause the video and then come back to check your work. Good luck. Now it's time to reveal the answers. And there you have it. Those are the 4 solutions that you want to look for. Pause the video so that you can double check your work. Quick notes, the first one just involved a greatest common factor of 8. The one down in the bottom right corner might have been a little bit trickier because my a was negative, but I think you'll find if you just try the X puzzle, you would make it work fairly well. You may have ended up having a negative in a different place, but most likely it's an equivalent statement to this if you have something relatively close. And the other 2 were fairly straightforward, just using X puzzles to solve. All right, hope you feel a little bit more confident now going forward.